Hey everyone, welcome back. So I got a quick chance to look at some of the footage from the previous lesson, just with the whole new setup of the Blackboard and all for just for today. It seems like the audio and video were both, I guess, a little bit better than I expected, but I totally get it if they were a bit worse than what you guys are used to with the whiteboard. If you guys do think that it is better, then I will continue recording with the Blackboard. But I mean, I don't tend to re-watch a lot of the videos after I post them, so I am not the best judge of how good the audio and video are. So just let me know, or have one of the teachers let me know what kind of works best for you guys, and I will just go with whatever's most convenient for you, because both options are pretty convenient for me. So in the last lesson, what we did is we went over one more example. We were graphing the function y equals 1/2 x minus 2, just to get a little bit more practice of working with the shortcut and of working with a slope that is not a whole number. So we were working with the shortcut with a fractional slope. So just one key thing to remember from the last lesson is that your slope is equal to your rise over your run, which in the case of the last question that we did was equal to 1/2. And so it's really as simple as just pairing off these two numerators together and pairing off these two denominators together and saying, okay, the rise is equal to 1, the run is equal to 2. So for every point that you have on your graph, if you move up 1 unit and over 2 units, that should get you to your next point. And as soon as you have 2 points that lie on the same line, you don't need a third and a fourth and a fifth point. You could simply put 2 points on your graph, one at probably the y-intercept would be where you start. Then you follow this sort of system to find another point, and then you can just draw your line right through that. Now, a question that some of you might have, though obviously I haven't heard this question yet, is when we were graphing the function that we just did, what we saw was we had our Cartesian plane, right? We had our Cartesian plane like this, and all the points were on the y-intercept or to the right of the y-intercept, right? All the points were somewhere over there. Now, a question that some of you might have is, can I plot any of the points over here, down on the left side? And the answer to that is yes, but you have to be a little bit careful. So actually, I shouldn't have erased the slope thing that I just had. So let me explain. So if we have a slope of 1/2, which is equal to, also we know that's our rise over our run. So this tells us that if we pair off these numerators, we get that the rise is equal to 1 and the run is equal to 2, right? Which we demonstrated over here. You go up 1, that's your rise is equal to 1, and you go to the right, that's your run is equal to 2. No problems there. Now, you can go in the other direction. The only difference is if you're going in the other direction, if you want to plot a point to the left, your run is going to be going this way, right? So instead of going 2 units to the right, we have to go 2 units to the left. Problem is that going to the left means that your run is negative now. It's -2. That's the positive x direction. That's the negative x direction. So if you're moving 2 units to the left, that's going to be a run of -2. So that means in your slope, you don't have a slope of 1/2 anymore. You've got a slope of, we need to figure out the rise, but the run is -2. So we have a negative kicking about in the denominator here for a second. The thing is, though, in order to get rid of that, we know that our slope is supposed to be 1/2, right? And what we have so far is we've got a denominator of -2. So there's only one number that we can really put up here in our numerator that makes sure that this fraction is still equal to 1/2. And the only number that we can put up here that matches these two fractions together is -1, because then these two negatives will cancel each other out and we're left with 1/2, or 1/2. Now if we've got a -1 in the numerator, that means we have to have a rise of -1. Now our rise is normally going up, but if we've got a rise of -1, that means we go down a unit. So then we've got a rise of, you can't really see that, a rise of -1. Sorry, that might be a little bit hard to see. But, so normally we go up and to the right, but it's exactly the same thing if you go down and to the left, or left and then down. And you could put another point here, and hopefully I've drawn this decently well, so you can see that it still lines up. It still lines up. You could still plot your points going down and to the left. Now obviously I don't have the whole grid and stuff lined up just yet, so you can't see it perfectly, but hopefully this gives you a good enough rundown of how something like this could work in practice. Now one thing we haven't yet done, which I will get to, maybe not in this lesson, maybe not in this lesson, but what we'll do in the next lesson is we'll revisit the idea of graphing, but with a negative slope. So far our slopes have always been positive numbers. Sometimes they've been fractions, sometimes they've been whole numbers, but they've always been positive. They've always been greater than 0. So what we're going to do today is we're going to practice with the information that we have so far. We know how to graph lines with a positive slope. We know how to graph lines with or without a y-intercept. That's different from 0. So with the information and experience that we have, we're going to try going in the other direction. We're going to try finding the equation of a line. So that's the subject of this video, is finding the equation of a line given a graph. Right? I have to give you the diagram, and then we can find the equation from that. So finding the equation of a line given a graph. So what we're going to do in this lesson, and possibly also the next one actually, is we'll just get a little bit of practice finding the equation of a line from the graph of the line, and then what we'll do in maybe towards the tail end of next lesson or the lesson after that is we'll revisit the idea of negative slopes. So we haven't really talked about negative slopes that much just yet, but we'll get to it, and it's really not that complicated. As soon as you understand the idea of negative slopes, you can graph a line where you've got a negative slope, or you could find the equation of a line where the slope turns out to be negative. It's really not that hard to figure it out. Once we get there, you guys will understand that it's a really, really straightforward concept once you just think about it for a couple minutes. So we won't worry about negative slopes just yet, but what we will do is we will start off, as we always do, by drawing our Cartesian plane. So I'm going to draw it similar to the one I had in the last lesson, except I'm going to space out the tick marks a little bit more, because we don't need to have 6 or 8 tick marks. 3 or 4 should be enough. So we've got something like that. Okay, that looks reasonably straight. So we've got 1, 2, 3, 4 going that way. Looks reasonable. 1, 2, 3 going that way. That's our positive y-axis. That's our positive x-axis. Don't forget to label those. And going this way, we've got 1, 2, 3. And going this way, we've got 1, 2, 3. Looks somewhat reasonable. All right. So we will. Let me run some tick marks or some thin grid lines through here. That's not the straightest. That's probably still not the straightest, but I think it'll do for now. Yes, I think that'll do for now. This one's a little bit off, but something like this. I do realize that I could have always drawn the Cartesian plane before I start recording, but on the off chance that some or all of you are doing this without graph paper, I'm trying to draw the Cartesian plane during the lesson so that you guys don't fall behind while you're trying to draw your own. So you guys can draw yours at the same time that I make mine, and that way we all stay pretty much on the same page and no one's falling behind just because they couldn't get their grid lines on the Cartesian plane in time. So we've got something like this. Looks reasonable to me. Put a few more up here. And then of course I still haven't labeled any of the tick marks, so I'll do that now. So here's our origin, and then going this way we've got 1, 2, 3. In the negative direction we've got -1, -2, -3. Going up we've got 1, 2, and 3. And going down we've got -1, -2, -3, and -4. Something like that should be plenty. And what I'm going to do is I'm going to list a series of points over here that we're going to all plot, and then we're going to see if we can figure out the equation based on that. So, points to plot. So you don't have to write out the list of points, but I want you to plot the points. And if you can't plot the points, I'm going to put them down here, then we'll plot them, and then we'll go from there. So the first point that I want you to plot is going to be at the coordinates -1, -4. Now remember, the x coordinate goes first, right? It's always x, then y. So find -1 on your x-axis, which is this one. And then once you've found -1 there, go down 4 units to the point -1, -4. Once you've found that, and if you haven't, that's okay, we're going to get there in a sec, I would like you to plot 0, -2, and then I would like you to plot 1, 0, and finally I would like you to plot, perhaps some of you have seen a pattern, I would like you to plot 2, 2. So if we start with the first point here, -1, -4. -1 on our x-axis is right over here, right? We start from our origin, we go 1 unit to the left, and then this point is telling us to go down 4 units from here. So from here we go down 1, 2, 3, 4, and we put our point right there. Basically what we're doing is, these are basically the values of our XY kind of table, right? We could have easily made a table out of this where we've got these values sitting in the table, and we've plotted them over there. The only difference is I haven't given you the equation to generate these values. I haven't given you the equation that tells you how to get these values. That equation is what we're looking for. Anyway, we're done with the first point. Second point, 0, -2. So 0 in the x direction, so we don't have to move left or right, but we do have to go down 2 units because of that -2. So from 0, we go down 1, 2, And that's it. We put a point right there. All right, great. Next up is the point 1, 0. So that's 1 in the x direction, so it's positive x direction. So we're going to go to the right this time. And then 0 in the y direction. So once we find our appropriate x value, we don't have to move up or down. So that's just our point right there is at 1 on the positive x-axis. And you might see the pattern now with where these dots are falling. But we've got one more point. We'll plot it just to be sure. So we're going to plot a point at 2, 2. So we go 2 units in the positive x direction. We go 2 units in the positive y direction. And we put our point right up there. So we've gone 2 units over and 2 units up because this point told us to go 2 units over and then 2 units up in the x and y directions respectively. And so that gives us 4 points, which we will now connect with a hopefully straight line. Something like that. If you have a ruler on you, please use it. I do not have a ruler or a meter stick that I could easily grab at the moment. Actually, that's a lie. I have a ruler I could grab, but this graph is far too big for me to try and use a ruler on. Now that might have come out a little bit, looks a little bit bent kind of around here. That's unintentional. That's just the fact that I free-handed this entire thing and there's no ruler markings or measurements or anything like that anywhere. It's a little bit off-center, but I think you guys get the idea of what we're trying to convey with this line. So what I'm going to do is I'm going to get rid of these points because on a test, I would give you that plot and I might highlight those dots in particular, but I would not give you these points. These points, it's your responsibility to read the values of those points off the graph. Now, if you wanted to, you could label each of the points on the graph for your own benefit, but I'm not going to give those points to you. So this is all the information that you will be given, and I will be asking you for the equation, and that's it. All right, so on a test or assignment question, that's all the information you get. You get that picture, you might have a few dots on it, no other numbers aside from the ones on the axes, and I'm asking you for the equation of your line. So, how in the world are we supposed to do this? The way this is going to work is, let's remind ourselves of what we know is the equation of a line. So we know the equation of a line is given by y equals mx plus b. This is just the way we do it every time, right? I mean, there are other ways that you could write out the equation of a line, but this is the way that we've been using thus far. And we're going to keep using it this way, at least for the time being. So from here, we know that we need to find a slope and we need to find a y-intercept. If we can find a value for m, and if we can find a value for b, we're good to go. And there's nothing more that we would actually need to accomplish, because when you look at the equations that we've done, the x and the y stay in the equation. We don't need this to all be numbers. We just need a number in place of m, and we need a number in place of b. So we're going to reverse engineer the shortcut. If we had a value for b, the y-intercept, so I'll label these. So m is our slope, and b is our y-intercept. So if we had a value for b, if we had a value for the y-intercept, it tells us where on the y-axis we should be plotting a point, right? That's the job of this number at the end here. So if this number was 0, we don't move on the y-axis, we plot a point at 0. If we had plus 7, then we would look on the y-axis, we'd look for plus 7 on the y-axis, and we would put a point there. If we have minus 1, we'd go from 0 down to here to minus 1 and plot our point there. So if we knew the value of b, we could figure out where on the axis it goes. But we have a little bit of information this time. We have a point on the y-axis. So we can reverse engineer that idea to get a value for b based on the point that we have on our graph. So normally, the value for b tells us where on the graph we need to plot our first point on the y-axis. But this time we have a point on the y-axis, so it should tell us what the value of b is. And so what we get from this is that we have a point at -2 on the y-axis, right? So this is at the coordinates 0, -2. And if your x-coordinate is 0, whatever that value over there is, whatever that y value is your y-intercept, is as long as your x-coordinate is 0. So that tells us that our y-intercept is equal to -2 in this particular question. For this particular graph on the right, our y-intercept is going to be -2. Okay, hopefully that's making sense. Now we need to find our slope, and this can be a little bit tricky, but all we need to do is remind ourselves, when we use the shortcut, how do we find the slope? Well, what we normally do is we make use of this formula. Slope is equal to rise over run. So let's just make use of that same idea. From, let's say, this starting point at -2, at 0, -2, how many units do we need to move up until we're in line with the next point? So the next point is this one over here. How many units do we need to move up from our starting point, which is this one down here, in order to be in line with that second point? So from here, if we move up 1 unit, that'll bring us to -1. If we move up a second unit, that'll bring us exactly in line with that next point over there. So this is telling us that we have to move up 2 units in order to be in line with that next point. So if we're moving up 2 units, that means our rise is going to be 2. All right, does that make sense? Hopefully that's making sense. So from here, we have to move up 2 units in order to be in line with that point over there. But we're not at that point yet, right? We're vertically, we've done our bit. We've gotten in line with that point. But right now, we're sitting over here on the origin, and we need to get over there to that point right there. So that's where our run comes in. And we have to move 1 space over, 1 unit over from the origin to get to that point over there. So from here, we went up 1 unit, up 1 more unit, so that's a total of 2 units up. And then we go 1 unit over to the right, and we end up at that next point right there. And so that tells us that our run is just 1, because we only had to move 1 unit to the right. So what we get from this is that basically what we had is we had our starting point, which if you look over in this corner, so we had our starting point, we moved up 1 unit, up a second unit, and then we moved to the right 1 spot, and boom, there was our next point. So what this part over here is telling us is that our rise is equal to 2. And what this part over here is telling us is that our run is equal to 1, right? That's what this part right here is telling us. So we had a rise of 2 and then a run of 1. And so what that does for us is this tells us that our slope is equal to 2 over 1. But if you have a number over 1, that's the same thing as just writing it as a whole number. So this tells us that our slope is actually equal to 2. All right, does that make sense? I really hope that's making sense. So what we get from this is we've now found our y-intercept is equal to -2, and we found our slope is equal to +2. So we've found all the pieces that we need in order to write out the full equation of this line. All that's left is to actually put it all together. So we have to replace m with the value that we just found for the slope, and we have to replace this plus b with the value that we found for the y-intercept. So if we write that out, we have y equals, the slope is now 2. Instead of m, we write down a 2. So we've got y is equal to 2 times x, because it's mx. So we've got 2 times x, and then this plus b, I put the plus in the box because we've got a negative sign in here, so we need to remember to bring that negative sign with us when we put the y-intercept into the equation. So we've got 2x from the slope and the x itself, but now for the y-intercept is negative 2. So we have to carry that negative with us, and we get an equation of y equals 2x minus 2, which I believe is one of the equations that we have tried graphing already. So it works out great if that is indeed one of the ones that we've tried graphing, because that gives you an opportunity to check what this graph looks like and compare it to that graph, compare it to the graph that we found for this function before. And what you should hopefully find, is that it is indeed y equals 2x minus 2. I really hope it is, because if it's not, that means I put in all this work at the end of a night of studying only to come up with the wrong equation of a line. So I really hope I don't have the wrong equation, but it looks right to me. The process looks right. I trust myself to be able to do this math correctly. So I am going to hope that this is indeed correct and that I haven't made any silly mistakes. It doesn't look like I've made any silly mistakes. So I'm hopeful that this is all correct. I'm going to, I know I would ordinarily extend this video a little bit longer and try and push it to about 35 minutes or so, but I know that you guys, for some of these videos, they've gotten really, really long. So I'm going to let you guys off with this one. I'm going to give my voice a little bit of a break because I've been up all night and talking to a couple of friends all night while we tried to study together. And this is the second video of the day. So it is only 27 minutes or so on the clock. It's a little bit shorter than some of the recent videos have been. And I know I've been saying it for like a couple of months now, but there actually is a surprise hopefully on your way within the coming weeks, as soon as my schedule settles down a little bit, regarding these lessons. More on that when I can actually confirm a date or a time or a topic or something. But yeah, there is a surprise hopefully coming your way, just as a little sort of fun thing so that you guys sort of get out of the monotony of having sort of the same setup and the same voice and the same everything over and over and over again. This will be the 48th lesson, I think. So I imagine you guys are getting a little bit sick of me, but yeah, I will keep you guys posted on that, and I hope you will keep me posted if you have any questions about any of this. But if not, then I will see you all in the next video. Have a good one.